What's going on? It's your boy Kenny T with Kilo Tango Aviation. This is the Airplane Flying Handbook, Chapter 3, Basic Maneuvers Summary. I'm breaking it down for you, make it so that it ain't so boring. You don't fall asleep trying to understand this stuff. This section is kind of long, but it goes through a lot of different things. It goes through the fundamentals of flying, flight controls, attitude flying, climbs, turns, descents, and glides. Let's jump right in. The 4 fundamentals. To master flying, a pilot must first master the 4 fundamental maneuvers. So that's straight level flight, turns, climbs, and descents. And all the maneuvers that you're going to do in any airplane is a combination of all of those. From takeoff to the ground, it's all that. A couple examples are takeoff. A ground roll transitions to a climb. Cruise is straight and level flight with occasional turns. And landing is descents, turns, and straight and level flight leading to the touchdown. And your flight instructor will ensure that your student can perform these maneuvers at a level that meets the FAA's ACS. Effective use of your flight controls. An airplane moves along 3 axes controlled by the primary flight controls. Your pitch, which is the lateral axis controlled by the elevator. The roll, which is the longitudinal axis controlled by the ailerons. And the yaw, the vertical axis controlled by the rudder. So now your elevator pitch control is pulling on the elevator control, so producing back pressure. So this moves the airplane nose upwards, raising the pitch. Think of this motion as moving the airplane's nose from your feet to your head. Pushing the elevator control forward pressure moves the airplane's nose downward, so lowering the pitch. So this is like moving the airplane's nose from your head to your feet. The key tip is make sure that you're smooth with general inputs, and that's essential to avoid any abrupt attitude changes. You gotta be real smooth with it. So your aileron, your roll control. So right pressure on the control, whether it's the yoke or stick, turn clockwise, rolls the airplane's right wing down, left wing up. This is going to be moving think about tilting your head towards your right hip. Left pressure takes control stick counterclockwise and rolls the airplane with the left wing down, right wing up, moving from your head to your left hip. So adverse yaw. So this is something that when initiating turn, the downward deflected aileron creates excess drag, which pulls the nose in the opposite of the turn. And so you got to use coordinated rudder input to offset this effect. So remember that. Then you got your yaw, which is the right rudder pressure. So moves the airplane's nose to the right. So think of this as moving the airplane nose from your left shoulder to your right shoulder. So in that kind of motion there, your left rudder pressure moves the airplane's nose to the left. So this is like moving the nose of the airplane from your right shoulder to your left shoulder. You want to make sure you got proper foot position on the rudder pedal. So rest your heels on the floor and apply pressure to the rudder pedal using the ball of your feet. Avoid riding the brakes by unintentionally pressing on the toe brakes. So the control pressure in the field of the airplane, the control surface of resistance increases with airspeed. The faster the airplane flies, the more pressure is required for the same control deflection. So you want to be light and use fingertip controls, and that's the key to being precise as a pilot. Gripping the yoke too tight reduces sensitivity. And during the rudder use, pressure should be applied smoothly and evenly to prevent abrupt yaw changes. So you're gonna have to learn how to develop the feel for the airplane. So things you want to look for, think about, well, not even look for, but listen for, feel for. So sound cues, so increasing airflow noise suggests that you're in a dive or you're increasing airspeed. Vibrating feedback, it means control surfaces and airflow produce distinct vibration based on the airspeed and attitude. And then other physical sensations. So kinetic effect like G-forces help pilots sense pitch and bank changes. But sometimes that can trick you. You got to understand how they actually work before you rely too much on that sensation. But just understand what you should feel when you put in different inputs. Next section is attitude flying. So an airplane's attitude refers to the angular difference between the specific axis and the natural horizon. So attitude flying involves a visual reference, so the horizon, wingtips, and nose, and flight instruments to control the pitch, bank, and yaw. So with the pitch attitude, the angle between the airplane's longitudinal axis, the nose, the tail, and the natural horizon, and it's controlled by the elevator. The bank attitude is between the airplane's lateral axis, so wingtip to wingtip, and the natural horizon. It's controlled by the aileron. And then the yaw attitude, which is the airplane's nose relative to the flight path. So not the horizon, but controlled by the rudder. So the methods for attitude control are either with VMC or with an IMC. In your VMC, pilots primarily use the horizon and external references to control the attitude. That's what you're using to determine how the airplane's moving. You position the airplane's nose and wings relative to the horizon, and it helps you indicate your attitude. When you're IMC under the hood, you're going to use your flight instruments to do this. So you're going to look at the artificial horizon and the attitude indicator and heading indicator to actually help you figure out how to do that exact same thing, how to look at the attitude of the airplane. So the integrated flight instruction is what instructors are going to use to help use both external visual references to flight instruments, simultaneously helping you establish and maintain your desired flight attitude. So part of this is primarily being able to learn how to focus on visual references. So 90% of your attention should be outside the cockpit, scanning for traffic and monitoring the pitch and bank attitude angles relative to the horizon. So you should be looking outside most of the time, and that's how you're determining if the airplane is banking, if the airplane is pitching, etc. And then you're going to validate it with your instruments. So you should be looking outside and then glance in to confirm what you see outside with what your instruments are. And then that way you can verify any deviation and put any corrections in. Only about 10% of your attention should be focused on the inside of the cockpit. So you should learn how to quickly analyze the instruments and make your corrections immediately, and then return back to visual references. This is also making sure you get familiar with the instruments in your aircraft, because if you're in glass cockpit or six-pack, it'll be slightly different on how you do your scan. So an example of the scan is if you notice that there's a slight left bank by looking at the horizon, and verify it by looking at the attitude indicator. The pilot then applies smooth aileron and rudder inputs to level the wings back by maintaining situational awareness of the traffic and the terrain. And we kind of talked about the sensory feedback. So common errors that you run into in this stage is over-relying on instruments. So having your head inside, focusing, trying to fixate on the instrument, or fixate on the horizon, or looking at the instrument and chasing the instrument. And anytime you start to fixate, you're going to start losing situational awareness. And the number one thing you want to do is maintain situational awareness. And the goal of this integrated flight instruction is for the pilot to develop automatic responses when visual reference and instrument cross-check becomes second nature. You should instinctively combine visual, instrument, and sensory feedback to maintain the attitude and performance of the airplane. All right, now let's look at the next section, which is straight and level flight. So straight and level flight means maintain a constant heading and altitude, no climbing, no descending, no turning. This might sound simple, but to do it consistently and smoothly takes practice and patience. All other flight maneuvers, including climbs, turns, descent, are basically variations of straight and level flight. If you can master flying straight and level, maintain that control, all the other things become a lot easier. It's important because straight and level flight teaches you how to control all your axes, so your pitch, your roll, and your yaw, and how to be coordinated. And it's one of the most basic flight maneuvers or flight controls that you need to be able to demonstrate. Most deviations from control flight are likely unintentional climbs and turns, and are rooted in poor straight and level flight techniques. So if you're not stable in straight and level flight, everything else is going to be way harder. So establishing visual references. So to fly straight and level, you need to have a solid visual reference. Starts with adjusting your seat. Make sure you're positioned so you can see comfortably over the instrument panel. Make sure you're fully depressed the rudder pedals without straining. You want to be able to make sure you can establish reference points from the airplane's nose and the wingtips relative to the horizon. So look outside, see the nose, see the wings, and be able to establish references based on that. Now, how to maintain straight and level flight. So when you're flying straight and level, focus on the airplane's wingtips relative to the horizon. If the wingtips are level, the airplane is not turning. So if you look out the left and the right, and you see the wings have the same distance from the horizon to the wingtips, they're level. If one wing has less sky or less ground showing, then that means that you're not coordinated and you're likely in the bank. You want to use small aileron and rudder inputs to keep your wings level. You want to monitor your heading indicator and look outside to make sure that you're still straight. If you bank your wings, the airplane will naturally turn. If you maintain a straight flight, apply an aileron to correct any bank. If you only use aileron without the rudder, the airplane will skid or slip, and you'll feel it. Also, avoid overcorrecting. If you notice you're a little bit off with the bank and you overcorrect, you're going to end up in even a more of an off situation. You're going to end up overcorrecting back, and you end up in this pilot-induced oscillation when you're going back and forth and back and forth. Also, now we're looking at also common errors. Like I said, don't overcorrect, and then don't fixate on the nose too much. You got to make sure you keep a good scan. So level flight is keeping your constant attitude without climbing or descending. We're talking about before was maintaining that straight flight, which is without banking. Now we're talking about level flight, which is how to keep the airplane from pitching up or down without climbing or descending. And you're going to use a horizon in the nose position as a primary reference for maintaining that level flight. So use the elevator to adjust the pitch and maintain your altitude. Monitor the altimeter and vertical speed indicator confirm that you're stable attitude. So when you're looking outside, wherever the nose is, you'll see where you have level flight, where you're not climbing or descending. You'll see where the horizon is, you'll see where your nose is. And when you can keep the airplane where that nose stays right there and it's not moving, that's a good indication of level flight. So so pitch control for level flight. So raising the nose increases pitch. So it increases lift and decreases airspeed. Lowering the nose, decreases pitch, increases airspeed. So there's a power and airspeed relationship. Airspeed remains constant if power and pitch are stable. If airspeed increases, raise the nose slightly to increase drag and reduce power if necessary. If airspeed decreases, lower the nose slightly to decrease drag and add power if necessary. Think of pitch and power as a balancing act. If your airspeed increases, you're gonna want to reduce that means that you're likely pitching over. Because the way they kind of explain it is, if your airspeed increases, raising those slightly to increase drag. And what's happening is, if you have the airspeed increase, that means your nose is probably dipped down and you're increasing airspeed because you're likely descending. So give that back pressure, and then if you have to, slow the airplane down by taking a little bit of power out. And this is where it comes with, you got to practice this a lot to figure out how to get the airplane right stable where you want it with a constant airspeed. You also want to make sure that you're not putting inputs in too fast. Don't put any inputs in faster than you can see what's happening and adjust it. So small inputs means small corrections. If you put big inputs, you're going to have big corrections. And also make sure you trim for level flight. So establish that attitude with pitch and power. So you should be pitch, power, and then trim the airplane to make sure that the airplane is doing what you want. And have a light control on the yoke so that you're not gorilla gripping, because that's not helpful. You want to make sure you cross-check your instruments. That's this section. So attitude, cross-checks, you want to confirm your pitch and your bank and your altimeter to confirm that you are stable and at straight and level flight. All right. Next section is a level turn. So what is a level turn? A level turn is exactly what it sounds like. Turn the airplane while maintaining a constant altitude. Here's the catch. When you bank the airplane, the lift vector tilts sideways. That means some of the lift is going to keep you in the air, and that was keeping you in the air is now going to turn the airplane. But that also means there's going to be total less lift, which means that the airplane is going to try to descend. So how do you fix it? You got to get back pressure, and depending on how much bank you have, you might have to add a little bit of power, but you're going to have to have back pressure to increase your overall lift. So how to perform it? Aileron, establish, maintain the bank angle. Elevator, maintain altitude by increasing the angle of attack. Rudder, maintain coordinated flight and eliminate adverse. Let's break it down step by step. So establish the bank you want. You start with the turn by applying a smooth aileron input in the direction of the turn. Apply just enough pressure to achieve the desired bank angle, no more, no less. Then maintain altitude with back pressure. Get back pressure to keep the airplane in the air, and then coordinate the rudder to avoid adverse yaw. And then monitor and adjust. Outside, outside, inside. So as you're going through it, look outside, look where the nose is at, see if the nose is dropping or if it's climbing too much, and then make your adjustments as you're going through the turn. And so how does the bank angle and airspeed affect your turn? So your angle of bank, the steeper the bank angle, the higher the rate of turn and the smaller the turn radius. However, steeper bank also increases the load factor, which increases your stall speed. With your airspeed, At a given bank angle, higher airspeed increases inertia, which means the airplane resists turning. The higher airspeed results in slower turn rate and larger turn radius. And then the opposite is true for low airspeed. So high rate of turn, small turn radius. So in a 172, 30 degrees bank at 100 knots will result in a much smaller turn radius than and a higher turn rate than the same 30-degree bank going 140 knots. So your four types of turns, you got shallow turns, which is less than 20-degree bank, and medium is 20 to 45-degree bank, and the steep turn is greater than 45. And then the last thing you do after you're done with the turn is the rollout. Start the rollout before you reach the desired heading and anticipate it about half the bank angle. Smoothly apply aileron in the opposite direction of the turn and level the wings. Next, we got climbs. So climbs happen when lift exceeds the force of gravity, but here's the catch. Increased lift also increases drag, which means you need more power to sustain a climb. And here's three main types of climb. You got a normal climb, which is fast, stable, and comfortable. Your best rate of climb, which is VY, which is your maximum altitude gained over time. Then you got your VX, which is maximum altitude gain over distance. So useful for clearing obstacles. To establish climb, you want to increase back pressure on the elevator, add power to climb, and adjust rudder for coordinated flight, and monitor pitch and airspeed. If you're doing a climbing turn, if you're climbing and turning, it gets a little bit complex, but really not too much. Some of the lift is diverted to the turning force, and so shallow banks are best for climbing turn. You don't want to climb too steep and turn at the same time, because you're going to need increased back pressure and power to maintain the climb rate while you're turning. In descents, it's essentially a controlled loss of altitude, and it's three types. Partial power descent, which is smooth and stable, a minimum safe airspeed descent, so slow, nose high, for short approaches, and emergency descent. That's high speed, high drag maneuver for rapid descent, rapid altitude loss. So you reduce power, start descent, use elevator control to control the speed, and then trim the airplane for a stable descent. And then we're talking about descents, we're going to go into glides. And glides are a controlled descent with little or no power. The best for maximizing the distance traveled per unit of altitude loss. And the glide ratio is the horizontal distance divided by the altitude loss. Use smooth pitch and rudder inputs to avoid slipping or skidding. And that's it for the climb and descent section. And actually, that's it for this entire section of the basic maneuvers. So we covered everything from the fundamentals, the effects of flight controls, what the aptitude flying is, integrated flight instruction, how you can do straight and level, turns, flight, trim control, level turn, climbs, climbing turns, descents, turns, glides, all that. Now, that got through quicker than if you went through and read it through. So that's it. Get ready for the next section. I hope that was helpful. Here we go.